An impossible particle spat out by an exploding black hole. I mean, it sounds completely like a sci-fi blockbuster, right?
Oh, totally.
But it is actual, literal physics. Welcome back to Casutalks. I've got my coffee, my notes, and as always, our resident expert here with me to help unpack today's wild stack of research for you.
I am so glad to be here.
Yeah.
And we really have prepared a great journey for you today.
We really have. Today's deep dive is fascinating because, well, the sources all connect to one big overarching question. How do the things we cannot easily see, from invisible particles to shadowed lunar craters to the unseen logic of autonomous robots, how do they shape our entire understanding of the cosmos?
Exactly. It's all about the invisible forces running the show.
Right. So let's just jump right into the deepest cosmic mystery on the list. Back in 2023, the CAM3Net experiment detected a neutrino.
Yeah, but this wasn't just any neutrino.
No, not at all. It had 100,000 times more energy than the Large Hadron Collider can even produce here on Earth.
Which, completely breaks our current understanding of things. There's no known standard cosmic process that just spits out a particle with that much energy.
It's wild.
It is. But physicists at UMass Amherst proposed an explanation. They theorize it actually came from a dying, evaporating primordial black hole.
Okay, wait, hang on. Evaporating? Because I thought black holes only swallowed things up.
Well, usually, yeah, you'd be right. But these are primordial black holes. They're basically microscopic relics from the very beginning of the Big Bang.
Oh, wow. So they're tiny.
Right. And as they lose mass over billions of years, they eventually become unstable and just explode.
That is crazy.
Yeah, releasing massive bursts of energy, which gives us our impossible neutrino. But the UMass team actually goes further. They suggest these tiny black holes carry a dark charge.
A dark charge. So like electricity, but for dark matter? I mean, that sounds less like physics and more like a sci-fi villain's secret weapon.
Haha, right. It sounds like a comic book.
Seriously. How does a dark charge actually solve the dark matter mystery, though?
It's actually a brilliant concept when you look at the source material. Just like normal matter has electrons and, an electromagnetic charge, they theorize dark matter has a heavy dark electron and a dark charge.
Okay, I'm following.
Yeah, so it explains why dark matter clumps together and exerts gravity on galaxies, but remains completely invisible to our light-based telescopes. The dark charge only interacts with other dark matter.
Wow, so the deepest mysteries of the universe might just be tiny, invisible black holes exploding all around us.
Literally all around us.
Incredible. But let's bring it a bit closer to home, to our own cosmic backyard, where the invisible is actually causing some very real practical problems.
Ah, you're referring to the Artemis II mission.
Yes. The crew just beamed back those amazing photos from the moon's far side, capturing that rare 54-minute total solar eclipse.
Stunning visuals, just beautiful.
Completely stunning. But the real story is what's hiding, or, well, rather what is not hiding, in the dark parts of the moon.
Exactly. NASA used the shadow cam on the Denuri orbiter to peer into permanently shadowed lunar craters.
Right, because for a long time, the assumption was that these dark, freezing craters were basically giant cosmic freezers, right? Just packed with vast sheets of water ice.
Which we desperately need.
Exactly, for drinking water and rocket fuel for future lunar bases. But the ShadowCam data says, well, no.
Yeah, unfortunately, it says no. The data reveals highly isolated small deposits, maybe just 65 to 165 feet across.
Oh, wow. That's tiny.
Right. It's not a vast winter wonderland down there. It's practically barren.
So basically, packing for the moon is less like visiting a snowy mountain resort and way more like crossing the Sahara. You had better bring your own water.
Haha, pretty much.
Yeah.
Or get really, really good at finding the tiny puddles.
Which has to create a massive logistical bottleneck, right? I mean, if water and resources are that scarce, human astronauts cannot waste hours just wandering around looking for them.
Exactly. They need smarter, faster scouts to survey the alien surfaces for them.
Enter AMAL. This is a semi-autonomous four-legged robot tested at the University of Basel, designed specifically for Martian and lunar terrain.
And the autonomy is really the key here. Currently, with our Mars rovers, there was a 22-minute communication delay just to tell a rover, like, hey, look at that rock.
Oh my gosh, that sounds exhausting. And Animal just skips that entirely.
Yep.
But how does it actually know what it's looking at without a human checking the camera feed?
It uses two main tools. First, a micro imager, which basically acts like a robotic magnifying glass to analyze the physical texture of rock.
Okay.
And then it uses a Raman spectrometer.
Right, I was reading about that in the notes. How does a Raman spectrometer actually work?
It's really cool. It basically shoots a laser at the target and measures how the light scatters.
Like a laser barcode scanner or something?
Kind of. Different chemicals scatter light in totally unique patterns, almost like a molecular fingerprint. So Animemal can instantly read those fingerprints to identify vital resources.
Like gypsum and basalts.
Exactly, all on its own.
And because it makes its own decisions, it cuts a standard 41-minute target analysis down to just 12 to 23 minutes.
It's incredibly fast.
It is. Though, if it's working 3 times faster and making its own decisions, how long until it decides it deserves a coffee break, just like us?
Haha. Well, considering it's out there hunting for the ice we need to literally make the coffee, we'd probably have to grant it one.
Fair point.
But seriously, this shift from human-piloted tools to autonomous field scientists, it changes the entire math of space exploration.
It really does. Which I think leaves us with a pretty fascinating thought for you to chew on today.
Let's hear it.
If our autonomous robots are getting this smart and invisible black holes might be exploding around us right now, what other invisible wonders will the next generation of space explorers trip over?
I mean, it's an exciting time to be looking up.
Always is. Well, thanks for taking this deep dive with us today on Casutalks. We'll be back tomorrow to unpack another stack of research just for you.
Don't forget to like and share.
Oh, yes. And to prove you stuck with us to the very end, jump into the comments and type the phrase exploding robodog.
Haha. Exploding Robo Dog, I love it.
Until tomorrow, keep wondering.